In question 3.1, we want to know what each of these lines in test animal's main method will print, given our previously defined classes, animal and cat, along with the additional dog class defined here. So inside of our main method, we have an animal A with name Pluto in age 10, a cat C with name Garfield in age 6, and a dog D with name Fido in age 4. And then each of them calls the greet method. So just a quick refresher on static versus dynamic types with regards to method lookup. During compile time, the compiler checks if the method exists in the static type. If it doesn't, it will go to the superclass and repeat. If there is no parent class, a compiled time error is thrown. And then during runtime, the method found during compiled time is run unless it is overridden. So going back to our instantiated objects, the static and dynamic types for each are the same. So there will be no compiling errors, and the greet method called during runtime will be that of each instance's dynamic type. So for a.greet, we will be calling this method right here. And then for c.greet, we're going to be calling this one. And then for d.greet, we're calling this one. Next, we have A equals C, which makes the dynamic type of A cat, but the static type, which is animal, stays the same. Then in line 12, we cast A as a cat and then call greet. So casting changes the static type of an object temporarily, so during compile time, the compiler thinks that A has the static type of cat and will look inside of the cat class first for the greet method, which exists. Then during runtime, this method is run since the dynamic type of A is also cat, so there is no method overriding occurring. However, in the following line, since A's static method did not change, the compiler will first look inside of the animal class for the method, and then during runtime, since A's dynamic type is cat, and the cat class overrides the greet method, the cat class's greet method is executed. Our final question with these classes asks what would happen if we added the following code to the bottom of main. So here we assign the variable A to a new dog instance. So A still has static type of animal, but now has dynamic type of dog. Since D has static type dog, the line D equals A will throw a compiler error because dog is a subclass of animal. Not all animals are dogs, so this breaks the class hierarchy. We can address this problem with casting. If we cast A as a dog, we're essentially promising to the compiler that at runtime, A will be bound to an object compatible with the dog type.